The good news is everything we know about inhomogeneous equations also works for systems of equations. And so in particular, let's revisit the concept of undetermined coefficients, but this time for systems. So let's find a particular solution xp to x prime equals ax plus f, where a is 7 minus 3, 8 minus 3, and the inhomogeneous term f is e to the 2t for e to the 2t. If you remember undetermined coefficients, the first thing was to check for resonance. And the way we do it here is by looking at the eigenvalues, because they play the role of roots of auxiliary equation in this case. Resonance. And that you can check the notes. So in this case, turns out the eigenvalues are lambda equals 1 and lambda equals 3. On the other hand, look at the right side. The right side has e to the 2t. So right-hand side has terms of the form e to the 2t, which would correspond to lambda equals 2. Notice this doesn't coincide with our eigenvalues, so there is no resonance. Doesn't coincide. And then no resonance. And in a future video, I'll show you what to do when you have resonance. And again, the beautiful thing is, if we just want to find a particular solution for undetermined coefficients, you don't need to look at the eigenvectors. You just need to check the eigenvalues for resonance. Okay. Now let's look at, let's do undetermined coefficients. Coefficients. So in this case, our inhomogeneous term, f of t is e to the 2t, and then 4e to the 2t, which if you want, just factor out e to the 2t here, e to the 2t, 1, 4. And again, what is undetermined coefficients? You guess your particular solution based on what the right-hand side looks like. And here, you just do it by analogy. So for scalar ODEs, e to the 2t would have given you ae to the 2t. So here we do the same thing, but instead of a, you have a vector ab. So here, so e to the 2t, 1, 4, that gives you xp of t is e to the 2t, but this time constant vector. So our guess is xp of t is e to the 2t ab, or if you want, for what comes next, is a e to the 2t and b e to the 2t. And the rest is as usual. You have your guess, and you plug this into the ODE. So once again, notice the similarities between this and scalar undetermined coefficients. Maybe that's step 3. So plug into our ODE, which was really xp prime of t equals axp plus f of t. So don't confuse this matrix A with that constant A. And so what we have is, so the derivative is ae to the 2t prime, be to the 2t prime, and then 7 minus 3, 8 minus 3, and then ae to the 2t, be to the 2t. So that was xp. and then the inhomogeneous term, which was e to the 2t, 4e to the 2t. So the idea is you calculate everything and then just solve for a and b. So the derivative here is 2a e to the 2t, and then 2b e to the 2t. For the rest, you just matrix multiply. So 7a e to the 2t minus 3b e to the 2t, and then 8a e to the 2t minus 3b e to the 2t plus e to the 2t, 4e to the 2t. And so really what this gives you, if you just compare both sides, 2a e to the 2t equals 7a minus 3b e to the 2t plus e to the 2t, and 2b, or not to be, e to the 2t is 8a minus 3b e to the 2t and plus 4e to the 2t. And of course, now notice those e to the 2t's, they all cancel out, and you end up getting a system of equations for a and b. So 2a is 7a minus 3b plus 1, and then 2b is 8a minus 3b plus 4. And you can now simplify this a little bit. So this becomes minus 5a plus 3b equals 1, and minus 8a, and then plus 5b plus 5b equals 4. And you can solve this with your favorite method. You can use Gaussian elimination or just do it directly, and then you will eventually find that a is 7 and b is 12. So what does that tell you now? So I think that was step 4 now, our answer. What is our particular solution? It's just e to the 2t times ab, which is e to the 2t times 7, 12. Or if you want, just optional, that's 7e to the 2t and 12e to the 2t. And once again, notice how similar this is with scalar equations. You first check for resonance using eigenvalues. You then guess the particular solution based on the right-hand side. And this you do it by analogy with scalar equations, and you solve for the constants. And the next video is more practice with that, with a more complicated example.